Hello everyone, and welcome back to this mini-series giving an overview of the developer-friendly features of the Kubro EXA8 platform. In this final installment, I'm going to be giving a short overview of the RESTful API on the EXA8 device. So again, great for developers, great for anybody who wants to create their own custom solutions. This will be perfect for anybody who's just interested in automating certain features based on triggers in their environment or scripting things out. So the RESTful API on the EXA8 is all documented in this file that will be available to any developers who want to use it. And this lays out all of the different calls that we can make, everything from showing memory usage to showing our active tapping sessions to configuring those tapping sessions. As I mentioned in the last video, this is going to be the primary way that you can interact with those input and aggregation interfaces to both configure those. So if we go down here, we can see we have configuring our ports to creating our tapping sessions, assigning our VLANs for our aggregation, all of that good stuff is in here. And in the documentation, we can see the HTTP method that needs to be used with each of these calls, the URI that we need to direct that at, some example usage here with things like curl and JavaScript and C and Perl and Python, so some really good information there, along with, of course, the query parameters that will be needed to make the call and the results that you can expect and the information that will be returned in the response. So there's really two methods, especially for people who want to develop on the device, that you can approach this API. The first is in a typical fashion where you are making a call to the web server and the URI added on the web server. And this is going to go through some various authentication measures. So we can see that when we make our login request, we're going to attach our username and password as parameters here. And our response is going to include our user ID, our username, and our role. But most importantly, our response is going to include our session cookie. So this session cookie will have to be attached to all of the requests that we send from that point on. Now, this can be handled pretty automatically through things like Postman, of course, and if you use the Python request library, requests session method will handle this all in the background without you needing to do a whole lot, but just be aware that that session cookie is there. So from here on out, we can do things like we can do a get request to system info, and we can pull down things like our memory, like total memory, free memory, CPU load, CPU temp, smart status, disk, and these will all be made with the additional header of X requested with an XML HTTP request. And some of them will require the header of application JSON as well. Now, of course, these are all things that you can see happen in the web browser. If you open up your developer tools, we can see all of these requests and responses being made right here. So this is another great resource if you want to use these and see what headers are being passed and what responses you're getting if you're troubleshooting something. But this is we'll get to that in a moment. So if we want to do something like configuring our interfaces here, let's take a look at this post request where we create a monitor session. So in this post request, of course, I'm going to have my headers here. So I have X requested with, XML HTTP request, content type is application JSON, and then I'm going to pass my parameters of the monitor session I want to configure, the source interface and the destination interface, and we're just going to post that to the URI designated here, and that's going to give us our result OK. Awesome. So this is pretty standard procedure for REST APIs if you're used to working with them. Another thing that we've done with the EXA8 is if you're running these from localhost, you can actually make these calls to localhost on port 8080. And this is going to bypass all authentication. So you won't need to handle the session cookie. You won't need to pass your username and your password into this, just for convenience sake. So we can make this a little more streamlined, reduce the amount of code that needs to be written so that people developing on the device can do this in a straightforward manner. So we can see here I can do something just like curl localhost 8080 at the URI for memory usage, and then I get my response there. I can also do this for API ports info, and as you can see, all of this comes back in a JSON format. So very friendly to handle in your various programming languages like Python. Now, to demonstrate in sort of a very generic and abstract way what we can do with this, I have created this example script here. So let's take a look at that. And please don't be too harsh with my coding practices. I am not a programmer. I'm not a professional. I am just a hobbyist. But what I'm going to do in this script is I am going to first clear all of my monitor sessions. So I'm going to remove all of the monitor sessions and start with a clean slate there. Secondly, I'm going to clear any aggregation VLAN tags from the XV interface, again, starting with a clean slate. And then I will configure my tapping session. So I'm going to make 2 calls here to configure my tapping session. You can see that I'm going to, on tapping session 1, I'm going to use a source interface of G1 and a destination interface of G2. And then for session 2, I'm going to do the inverse of that. So I capture my bidirectional traffic, creating that tapping session. Now I'm going to just go ahead and grab all of that active tapping session information so I can verify that those settings took effect. And then we're going to configure our aggregation. So here we're going to assign our VLAN tag of 100 to the G1 and G2 interface. And then in this function, we are going to assign that VLAN tag of 100 to the XV interface. So now I have my aggregation. All of the traffic going across G1 and G2 will be output to the virtual interface of XV. And then I'm going to, again, just grab that input VLAN information and output VLAN information to verify that those settings took effect. And finally, I'm going to initiate a TCP dump capture on the XV interface for 10 seconds, and I'm going to write those results to script.pcap. And then that is going to hopefully work out. So let's go ahead and run that. We'll see that we start getting our output immediately, and now we're running our TCP dump. This will run for a few more seconds before this process will be terminated, and will be dropped back to the prompt. So let's just review the output information that we have there. So the first step was clearing all of my monitor sessions of their interfaces. So we can see here that for 1 through 12, we have a status response of 200, meaning all of those went through great. We're going to clear our aggregation VLAN tags from the XV interface. Again, status of 200. Now I'm going to configure my monitoring session. So this is where I assign the tapping sessions to interfaces G1 and G2. Again, status code 200 and result OK for both of those calls. And now I'm going to return my active tapping sessions. You can see that I have G1 to G2 and G2 to G1, and then the rest are blank. And then configuring my aggregation, so assigning VLAN tags 100 VLAN tag 100 to our G1, G2, and XV interfaces. So we can see 100 on G1, 100 on G2, and actually 100 on all of these interfaces. And then 100 on the XV interface. And at this point, I'm ready to start my packet capture. So that's where we call TCP dump, pass the arguments that we need to that, and create the pcap file that we can see here, script.pcap. So if I cat that, we can see that we have, for 10 seconds, all of the traffic that was traversing those G1 and G2 interfaces. Now again, this is kind of an abstract, generic example of how this can be used, but perhaps we are doing this based on an alert from a SIEM. So maybe we're making API calls to our SIEM, or our SIEM is pushing information out to another device, and we can use that to determine how we want to configure the EXA8 and then capture traffic accordingly. Maybe it's a firewall alert. It could be triggered by anything in the environment. And of course, you can do this with TCP dump, T-Shark, whatever comes to mind, whatever creative method that you can put together to accomplish any task is perfectly valid here. And that's really where this all goes, right? This all goes back to the developers and the creative engineers out there, the programmers and the hobbyists. How can you use this? What can you do with this? And remember, there is still time to enter the Elevate the EXA8 challenge. So if you have an idea for an application or how you can put this stuff to use, go ahead and head to that URL. I'll put that in the description of this video, and you can enter the EXA8 challenge for a chance to not only win an EXA8, but also $5,000. So until next time, thanks for watching, everybody, and take care.